Okay, a luggage lock opens with the correct 3-digit code. Is a code the same as a 3-digit number? No, a 3-digit number can't start with a 0. A code can. Correct? We have to read that carefully. Yeah, I can't even speak. The luggage lock opens with the correct 3-digit code. Very important. Each wheel rotates through the digits 0 to 9. Every time there's a word on a page, you will read it. Okay? Common errors happen in the people who believe like they've seen something a whole bunch of times, they just know it. So you kind of just skip and bypass words. And then I'm like, oh, where was the error? And often it's, I didn't read. We don't want that to be the error. Okay? So let's read. How many different 3-digit codes are possible? Does it say I can't repeat or anything? So I assume that I can, correct? The only one that it doesn't have to say that I can't repeat is like a word, like English, correct? You have what you have. So they don't have to say I can't repeat these. They give you the word English and that's what you get. So 3-digit codes are possible. So I can start anywhere because there's no restrictions, right? If there's a restriction, I have to start there. So this would be 0 to 9, which is 10, and then this would be 10, and this would be 10, and we get 1,000. And then if this is a test, we'd write a sentence, right? Okay. Here it says, suppose each digit can be used only once in a code. So now they're not letting you repeat. So we have to box and hold, right? How many different codes are possible when repetition is not allowed? So when repetition is not allowed, we box and hold. And like I said, don't tell someone else that you box and hold. They'll have no idea what you're saying because I made it up. Okay? So we can start anywhere because there's no restrictions. We have 0 to 9, which is 10. Then I box and hold, let's say, the 0. Then I have 1 to 9, which is 9. Box and hold the 1. And then I have 2 to 9, which is 8. And make sure you have the dots, correct? Because a lot of people will just have the number 1098. If you don't have the dots, that's what you have. Okay? And that's 720. The next one says an Alberta license plate has 3 letters followed by 3 digits, for example, ABC 123. The letters I and O are not used to avoid confusion with the digits 10. So I-O is out, but 10 is in. How many different license plates are possible? Does it say anything about can't repeat? No. So there are 26 letters in the alphabet, but I can't use I and O. So how many are here? 24, 24, 24. And then the back is 0 to 9, correct? Which is 10, 10, 10. And what do we get? What is it? Okay, we're bypassing this. 1 second. Everyone paying attention, put your pencils down. Going back into elementary school, so that you guys will answer me instead of being fearful of saying what the numbers are. All right. If I give you this, what number is that? 323. Done. Now you can read any number in the world. Did you know that? Let's watch. All right. Let's go. What number was this? And what spot is it in? Millions. What number is this? 576, and it's in the thousands. And what number is this? 3. Okay, get ready, people. 323 million. 576,000. 3. It's literally all there is to it. So if you can read a 3-digit number, you can read any digit numbers. Correct? This is what number? It's in the billions. What number is it? 26 billion. 5. What spot is it in? Million. 463,501. That's it. 26 billion, 5 million, 463,501. We're literally saying three-digit numbers with the words billions, millions, thousands behind it. That's it, right? So, what is this one? Yeah.
13,824,000.
That's just it. Exactly. 13,824,000. Finito. Right? Don't let a number throw you off. And if your brain fell out of your head and you don't remember that, you can say 13824,000. I won't judge you. I will judge no answers. That's all I'm going to do. Read every single number singly. I'll write it down. We will move on. And no one will judge you. Okay? Because of the growing number of vehicles in the province is changing its plates with 3 letters followed by 4 digits. And a lot of people think that doesn't make a big change. So we would have 24, 24, 24. And then at the back I have 10, 10, 10, 10. Multiplying by 10 just gives you an extra 0, correct? So we go from 13 million to 138 million. It bumps it another number. That's substantially more license plates, correct? So it's 13,824,000. It's going to bump me one more 0, so I'm going to get 138,240,000. So it gives way more license plates, right? Gives you an extra 0. Why are you doing that, left?
We just did how many more it would be since it says how many more. So if we did that.
Oh, you actually answered the question?
Yeah.
Okay, cool. So we're going to subtract 13,824,000. And how many more is it?
124,116,000.
Boom. So much smarter than you. Lexi gave the look and then Mackenzie talked. That was a good teamwork. Good teamwork. Okay. All right. Diploma questions 1 and 2. Go. Try them out. So here it says, Sally wants to decorate one wall in her room with movie posters. She'll hang 5 of the 8 posters that she owns in a single row. So she's only hanging 5. And it's a permutation because order matters because they're being hung on a wall, correct? If she just took the posters and then threw them in her closet, does the order matter? No, then the order wouldn't matter. But the moment you start placing them, you could physically, if you could physically take a picture and it would look different if you moved them around, then order matters. Okay? So which means that we can use the fundamental accounting principle. It's the only thing we know how to do, so we kind of give it away that we have to use it. It's the only thing you've been taught. All right. So it says that Sally places her, so we need to hang 5 of 8. Sorry, I got sidetracked. If Sally places her favorite movie poster in the middle, then the number of different poster arrangements. So she places her favorite here. How many favorites does she have? 1. How many have we used up? 1. How many do we have left? 7. So we have 7 for this one. Then we leave one of the posters there. This might be poster 1. 2. We leave it there. Then this is 6. Because you have to leave posters behind. If we don't leave a poster behind, we're never actually putting up posters, right? We're like, yeah, I like this one. Okay, I'm going to put it here. And then I'm going to put it, and then, like, that would be dumb. You never have posters up, okay? So it can't be 7, 7, 7, 7. We have 1, we place it. We have 7, we place 1. We have 6. Then we have 5. Then we have, and how much is that? 840. Do that. We're going to look at this one together. So if you haven't attempted it, no big deal. Cool. Okay. Cool. I don't know. I need to break as much as you guys do, except I don't even get to break. I just have to sit there and be a student for 4 days. Yay. All right. From 1951 to 1981, the first digit of every 3-digit area code in North America was a number 2 to 9. So that's the first digit. Inclusive means including 2 and 9, right? The second digit is either 0 or 1. The last digit Depends on the following rules. Okay, so we have some rules. If the second digit is 0, the last digit can be 1 to 9 inclusive. If the second digit is 1, the last digit is 2 to 9 inclusive. So we get different cases depending on if we use 0 and 1, right? So we're going to need how many cases here? 2. We're going to have a case where the middle is 0 or a case where the middle is 1. We agree? So here it says digits can be used more than once. The number of different area codes that could be possible with these restrictions. So because the ending is different if you use 0 or 1, we have to do different cases. So we do case 1, where the middle is a 0, or case 2, where the middle is a 1. What do I do when I use the word or? Add, because and add don't go together. They're so similar they hate each other. You know what I mean? So, or we add, and we multiply. Okay? So let's discuss this. So, do I need to box and hold? No, because it says the digits can be used more than once, right? So we don't have to box and hold anything. That's only if we can't repeat. So we have 1 here. Then we have a restriction on the first digit. It can be 2 to 9. Please don't be too cool that you don't use your hand. 2, 3, 4, 5, 6, 7, 8, 9 is actually 8. A lot of people will put 7. You look like a dork. You don't look like a dork if you use your fingers, but you look like a dork if you put 7. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9. 8. Okay? So we have an 8 in the first blank of both. And a 1 in the middle. Now it changes whether we have a 0 or if we have a 1. If we have the second digit as a 0, we get 1 to 9 inclusive. If the second digit is a 1, we get 2 to 9 inclusive. 1 to 9 is 9. 2 to 9 is 8. So for this one, we're going to get 72 different options plus, so 72 options if we use a 0 in the middle, or 64 if we use a 1 in the middle, which is 136, which is B. Okay? Then flip over. All right. 3 and 4, go. So this one wants how many distinct 4-letter arrangements. Sometimes you're using all the letters in the word. Sometimes you're using some of the letters in the word. The moment it's a word, you can do blanks, right? Make sure no phones are out. All right. So you have the word script. S-C-R-I-P-T, correct? How many letters is in script? 6. Okay. So 1, 2, 3, 4. So does it restrict it? Like I have to start with an I or end in a P or anything like that, or start with vowels? No. So we can start with any of them. So S-C-R-I-P-T. So that's 6, right? When it's a word, I have to box and hold something. So then I would have S-C-R-I-P, which is 5. Then I would have 4. Then I would have 3. Do I have to show the letters below? No. Can it help you out, though? Yes. Okay? And so this gets you how much? Okay, the next one is how many 5-digit odd numbers, it should say with an S, there are without repetition. Okay, we did 4 in the example in the notes yesterday. We're just doing 5 digits, so we're going to have 5 blanks. In order for it to be odd, what does that mean? It has to end in an odd number. Yes. So our options are 1, 3, 5, 7, or 9, right? So we go 1, 3, 5, 7, 9, which is 5 options. And I have to read without repetition, which means I'm going to box and hold. We agree? Yep. So say I box and hold the 9. I would have 1 to 8 here. Why don't I have 0 to 8? If it starts with 0, then it's a 4-digit number, not a 5, right? So when I say 5-digit number, that means that it can't start with 0. When I say 5-digit odd number, it still can't start with a 0 and has to end in an odd number. So there's 2 restrictions I have to do. Okay? So this would be 1 to 8, which is 8. Box the 8. Then people will tell me it's 1 to 7. What's the catch on this one?
0.
0 still. So we get 0 to 7, which is actually 8. Hold the 7. We get 0 to 6, which is 7. Hold the 6. We get 0 to 5, which is 6.
What does it say?
So what is 8 times 8 times 7 times 6 times 5?
13,400.
Now, if you're someone who forgot you have to do an odd digit, write that. These are your notes. Your notes are for you to study from, correct? The reason why we're doing open book on the first 4 exams is to teach you guys how to write proper notes, right? If you have an open book, you can look back. Do you agree? So, if you're someone who's like 1, 3, 5, 7, 9, I did not do that. You put a little arrow and you say odd numbers. Make it odd. Make it odd. Right? And then here you say can't be 0. When it's a 5-digit number, correct? And then some people forget here. What do you have to do here? Box and hold and put 0. Remember, 0 can come back. Yeah.
Why is it 1 to 8, and why is there an even number? It's supposed to be odd.
It's not saying that every number needs to be odd. How do you know it's an odd number? 23. Yeah, still started with a 2. 2 is an even number. Doesn't matter what it starts with. Can it start with an even number and still be an odd number? Like you're saying this can't be even, but you just told me 23 is an odd number. And I started with an even number.
Well, yeah, but that's just an 8.
These numbers just can't be 0. Because like the number 4, 4, 4, 4, 6 is even, correct? But 4, 4, 4, 4, 3 is odd. We agree? This is the only one that has to be odd in order for it to be an odd number. These can be anything else. So you're saying, why can this be 1 to 8? Because this can be any number but 9, because I boxed and held 9. This can be the number 8, correct? And this still be an odd number. Can this start with an 8? Can this start with an 8 and still be an odd 5-digit number?
Oh, okay.
Still odd, right? Am I starting with an 8? Yes, because I boxed and held an 8. But does this 8 represent that I started with an 8? No, this is 8 options, correct? So an odd number just needs to end in an odd number. Does it make sense? You're not alone. There's probably a few other people that are just silently dying inside right now. But do you understand that that can start with like an even number and it's totally fine? Does that make more sense now? Yeah. Okay. Homework questions. 1, 2, 3, 4. And then we have 5, 6, 7. And then we have 8, 9. Go. We're going through them together. So you guys are going to work on them or go through a few. So this here, I just want to draw your attention to number 5. It says repetitions are not permitted. They're also not permitted in B as well. It's not specified very well, but you can't repeat here as well. Okay? I also want to draw your attention to number 2 because it gets done really badly. So number 2 says, with new renovations completed at Holy Trinity Academy, there will be 7 entrances. And how many ways can a student come in from for math tutorials if they enter and exit through any entrance? So I get people putting 7 blanks. If you put 7 blanks, you're entering, then you're exiting, then you're entering, then you're exiting, then you're entering, then you're exiting, then you're entering, and now you're at math. And that is weird. So what is it, 7 blanks? How many blanks is it going to be? I need to enter, and then I need to exit. So my enter is 1 blank, and my exit is 1 blank. So how many blanks do I have? Those. Yes. Not 7. I have an enter, and I have an exit. And I'm kind of dizzy right now, actually, from doing the enter exit thing. So try 1, 2, 3. We're going to keep going through all of them, correct? In about 5 minutes, I'm going through 1, 2, 3. Probably 4. So the first one, it says how many ways can we arrange 6 different math textbooks? So they all look different, and we're arranging them. So we're putting them side by side by side, right? 1, 2, 3, 4, 5, 6. What I get a lot of people doing is they go 6, 6, 6, 6, 6, 6. If I have 6 textbooks, and I don't leave one behind, and I now have 6 more textbooks, and then I don't leave one behind, and then I have 6 textbooks, and then I don't leave one behind. Am I ever leaving a textbook behind? Am I ever arranging textbooks? Am I ever leaving some on a shelf? No. So some people say, well, it didn't tell me I can't repeat. Guys, we're trying to put 6 textbooks on a shelf, correct? So I have 6, and then what do I have to do? Leave one, right? Now I have how many? 5, yes. So I have 6, then I have 5, then I have 4, then I have 3, then I have 2, then I have 1, which is, fun fact, rocket counting. Now, is that rocket counting? Well, let's talk about it. Let's go to kindergarten, when they taught you how to count backwards from 10. 6, 5, 4, 3, 2, 1, blast off. We agree? That's rocket counting. If you can rocket count, you can use the factorial symbol. So, what the heck is that? It sounds like 6 is screaming. That's what it is. It's 6 exclamation mark. So if I can rocket count, if I can go 6, 5, 4, 3, 2, 1, blast off, I can use the blast off, which is the factorial symbol. Okay? For those of you who went 6 times 5 times 4 times 3 times 2 times 1 and got 720, we're all going to do 6 factorial now. So where do we find it? Go to your screen. Main screen of your calculator. And you're going to go 6. Sorry, this is the one. Oh my God. Computer that does not have calculator that does not have this. So we're going to go, or the computer doesn't have a calculator. We're going to press those 6. Then we're going to press the math button. And we're either going to arrow right or arrow left once or twice, depending on what calculator you have, to PRB. You can arrow right or you can arrow left to PRB at the top. Oh. And then it's number 4. Wow, these are some very excited people. And then press enter or 4.
It's actually exciting.
And what answer do you get? Same answer, right? It only works if you can rocket count. If you have like 6, 3, 2, 1, can't do it, right? It needs to be like you're in kindergarten and you're counting backwards and you say blast off. Then the blast off symbol can be the factorial. Okay? So they can just give the answer of 6 factorial too on the diploma if they want to. Or 700, I don't know what I'm writing, 720.
Fun in math.
If you say it more aggressive, they find it. That's what I'm saying. If you can't see the math button, you just say it louder. And then
Right.
trust it. All right. We talked about the entering and exiting one. This one says there's 7 entrances, which means there's 7 exits as well. Enter and exit through the same enter and exit through any entrance. So if I have 7 to enter through and I have 7 to exit through, so that's 49. Next one says enter the school and exit through a different entrance. So we enter, we have 7 options. If I have to exit through a different one, how many options do I have? 6, 42. Enter and exit through the same entrance. So I'm entering through 7. How do I guarantee that I exit through the same one? 1. Whichever one I entered through, which is 7. The next one says the score at the end of the second period of a hockey game is Flames 6, Oilers 3. Remember, game start at the score 0-0, which they will not give you on the diploma. I'm like, remember, it starts at 0-0. Matthew Kachuk was trying to determine how many different possibilities there are for the score at the end of the first period. He used the fundamental counting principle, and he multiplied 6 by 3 to get 18. He is wrong. So how many options do I have for the Flames? 0 to 6, which is 7. Yeah. And then I have 0 to 3, which is 4. And what do I get? 28. And to explain your reasoning, you'd have to say that Kachuk made an error because he went from 1 to 6. And then he went from 1 to 3, and he forgot that the game started at 0-0.
Why is Kachuk even trying when he was there and he should know the score anyway?
Because he was struggling. He was struggling. Okay? Oh my gosh. 4. If each of the students in a class of 30 are capable of winning any of the class prizes, how many ways are they for awarding first, second, and third? Can one person win first, second, and third? No. So the first place prize, how many options would I have? 30. And then the second place prize? And then the third? And when I multiply those, what do I get? 360? The next one, the math prize, chem prize, physics prize. The little genius child, the little valedictorian person. Can they win all 3? So I would have 30 options for the math prize, and then I would have 30 options for the chem prize, because they could win both, correct? And then 30 for the physics prize. This was not me, just so you know. But there's someone in the world that this could happen to. 27,000. Okay. We have 5. I told you that it can't repeat in A, and then I told you it can't repeat in B, even though it doesn't specify that. 6, does it have to say it can't repeat? It's the word shipwreck. You have one S, one H, one I, one P, one W, one R, one E, one C, one K. Correct? So it can't repeat because you only have that many of each. 7, you have a specific number of digits that you can use, 1, 5, and 8. It's not open for interpretations. So get going. I'm going to give you about 5-ish minutes again. Go. Okay, so this one says 3-digit numbers are formed from 2, 3, 5, 6, 7, and 9. So I'm not giving you all the numbers, right? I'm just giving you some. If repetitions are not permitted, and like I said for B as well, how many 3-digit numbers can be formed? So it doesn't say anything about what could be anywhere, so we can use any of them. The catch is that we have 2, 3, 5, 6, 7, 9. Some people pull me over and they're like, but I have 0 to 9. Cool, they didn't give you that option. Yeah. So 2, 3, 5, 6, 7, and 9 is 6 options. Then what would I have? 5 then? 4 because I'm not allowed to repeat, which is? Yeah. So at maximum, every answer below in B better be below 120, correct? Because 120 is the maximum numbers I could get. And B restricts a whole bunch of stuff. So if I'm getting an answer higher than 120, I should be a little suspicious that I did something wrong. Okay? The next one says less than 400. Well, less than 400 gives you a hint to the first digit. What can the first digit be? 2 or 3. It can't be higher than that, or you would have 400 and something, 500 and something, right? So it says it has to be less than 400. The only digits I can use are 2 or 3, because a 5 would make it 500. A 6, 7, or 9 would make it too big, right? So I have 2 options. Then I have to box and hold one of them. So I'm picking the 3. I could have picked the 2. It doesn't really matter. But now I have 2, 5, 6, 7, 9. Because once I start with a 2 or a 3, the number will be less than 400 no matter what I follow behind with, right? So then this has 5 options. Box the 9, then I would have 4. So this is 40. 2 says even. Well, in order for it to be even, it has to end in an even. So the even options are 2 and 6. That's it. So I have 2 options. Say I box and hold the 2. Now I don't have to worry about any restrictions on the first or second blank because there is no 0 option, right? Like it can't correct you up. So I use the 2. Then I would have 3, 5, 6, 7, and 9, which is 5. Box and hold, let's say the 9. Then I would have 3, 5, 6, 7, which is 4. And again, I get 40. There are going to be more odd numbers because I actually have more odd number options, correct? I only have 2 evens. So odd, I have to end in an odd number, so it could be 3, 5, 7, or 9, which is 4. And then I have 2, 3, 5, 6, 7, which is 5. That box is 7. Then I would have 2, 3, 5, 6, which is 4. And then this is 80. Multiples of 5 would be like 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. What's happening? They're ending in 5 or 0. Do I have the option of 0 though here? No. So saying multiples of 5 means I'm going to have to end in a 5, which is one option. I could end in a 0 to be a multiple of 5, but 0 isn't an option I'm allowed to choose. Right? So I boxed and held the 5. Then I have 2, 3, 6, 7, 9, which is 5. Say I hold the 9, then I have 2, 3, 6, 7, which is 4. And that's 20 off. Then we have the word shipwreck. Shipwreck has 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. No repetitions, because we haven't dealt with repetitions yet. That's going to happen tomorrow. So it has 9. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Is it 9, 9, 9, 9, 9, 9, 9, 9, 9? Exactly. So would it be 9, 9, 9, 9, 9, 9, 9? Is that even the biggest issue? What's the biggest issue? Yeah. It's a 4-letter word. You guys are reading that right now. On text, you don't. You guys do 9 blanks every single time. Will they have 9 blank options there for you as an answer? 100%. And it's often picked more than the 4 because you guys don't read. You just get excited. You're like, I can do this question. I'm really good at it. So I'm not really good at reading. Okay. So now would it be 9, 9, 9, 9? No, what would it be? 9, 8, 7, 6. Why are we dropping it by 1? It doesn't say I can't repeat. So people fight me all the time. You don't have infinite of each of them, right? You have one S, one H, one I, one T. So what's 9, 8, 7, 6?
3024.
Okay. The next one says contains only consonants. So that means not the vowels. So S, H, P, W, R, C, K. So how many consonants are there? 7. So now I have 7, 7, 7, 7. No, what do I have? 7 then, 6 then, 5 then, 4. And what does that result in? 840. B says begin and end in a consonant. Does it give us anything about those 2 middles? They can be anything, correct? So if it begins and ends in a consonant, that's what I have to deal with first. So begin, how many consonants do I have? 7. Then I have to end in a consonant. 6. It drops by what? We agreed? How many letters have I used up? 2. Let's pretend I've used up the S and the H just so you can see it. Visualize it, right? How many letters do I have left? 7. A lot of people put 5, 4. No, you have 7. You used up the S and the H, correct? So now we have 7. Say we use up an I. Now we have 6. So what do we get? Perfect. Begins with a vowel. We always deal with our restrictions first. How many vowels are there? 2. There's I and E. So there's 2. Say I hold the E. I've used up 1 letter, correct? How many do I have left? 8. then 7, then 6. So what do we get?
17.
Contains the letter P. Does it say where P needs to be?
Nope.
So we could put P at the front, which is 1. How many letters are left? 8, 7, 6. But how many places can P be? 4. There's P at the front, then there's P at the second, and there's P at the third, P at the fourth, right? So I'm going to get how many cases? 4. So I can times it by 4. Or you could go 1, 8, 7, 6, then put the P in the second one, go 8, 1, 7, 6, and put P in the third, and go 8, 7, 1, 6, and go 8, 7, 6, 1, and then add up all 4 cases, which will end up the same thing.
1344.
Pardon?
That's how many? That's how
Yeah,
many.
but how much was it, sorry?
1,344.
Begin with a K, end in a vowel. How many K's are there?
1.
Hold it. Vowels, I have I and E. So how many do I have? 2. Hold one of them. How many letters have I held now? 2. How many do I have left for the middle blanks? 7. 6. 84. Seven says, how many different 3-digit numerals can be formed from the digits 1, 5, and 8 if they can't repeat? So I have 1, 5, and 8, can't repeat, 3-digit numeral. Does it say I have to start with a 1, end in a 5, odd number, anything like that? No. Just can't be repeated. So this first, then I can start on the far left because it doesn't matter. So I have 1, 5, 8, which is how many? 3. Hold the 8. Then I would have 1, 5, and it would be 2, hold the 5. Then I would have 1. So this is 6 options.
Yep.
The next one says, how many different 3-digit numerals, now it changes, can be formed from 1, 3, 5, 7, 9 if digits may be repeated? Am I boxing and holding now? No. So I would have 5 options for the first blank, then 5, then 5, which is 125. What was box your answers? You worked hard to get them. Okay. How many 4-digit numerals can be formed from 0 to 3 if the digit may be repeated? Well, obviously it's going to have to be repeated. I didn't even give you enough numbers to make a 4-digit not repeated, right? So, people tell me it's 3333. Is that true? What's the first one? 2, 3. What can't it be? 0, or it would be a 3-digit, correct? So this is 2 options. Then this would be 0, 2, 3, which is 3, then 3, then 3. And make sure you're multiplying. So it should be 54. D is a bit tricky. B says how many non-zero numerals are possible using some or all of the numerals. So it says non-zero numerals. So non-zero means that 0 can't count. So I'm going to show you what a non-zero would look like. And then if it just says how many numerals. So using some or all. It doesn't say I have to use all of them, right? So if it's non-zero, I could have a 1-digit number, correct? This one just can't be a 0. If it says numerals, this one can. So I'm just showing you the differences, okay? So non-zero, you would have 1, 2, 3 as your option, which is 3 to make the first digit number, correct? They don't often say non-zero. They'll often say 0 can count. So then this would be 0, 1, 2, 3, which is 4 options, right? Just the difference in getting that one extra number. So I can make a 1-digit number from these 4, correct? What else could I make? A 2-digit number, correct? or means add when I get a new case, a 2-digit number. What's the catch? No, can't start with that 0 or be a 1-digit. So I have 1, 2, 3. And it says I can't repeat, so I need to box and hold, right? So that's 3 options. Hold the 3, then I would have 0, 1, 2, which is 3 options. Same thing happens here. 3, 3. For the same reasons, right? Could I have a 3-digit number with those? 0, 1, 2, 3? Yep. Just needs to start in a 1, 2, 3, which is 3 options. Box the 3, let's say. Then 0, 1, 2, which is 3 options. Box the 2. Then 0, 1, which is 2 options. So same thing over here. 3, 3, 2. Could I have a 4-digit number? Yeah, could I have a 5-digit number? No, so we're going to have to stop at a 4, because I only have 4 numbers to choose from, and I'm not allowed to repeat, right? So this one would have 3, 3, 2, 1. So this one I would get 3 plus 9 plus 18 plus 18. 36, 45, 48. And this one should be 49. Okay, then we're going to flip over. Try the last 2 out. Tomorrow we move on to permutations, and permutations is repetition, and then we have combinations, then you're actually done the unit. So the unit can go quickly. We're not doing it that fast. We're not doing a lesson a day, but it could go that fast. It doesn't. We go through the